Hello students, good evening. Yes, hope you all doing good. Now today we are going to discuss about a very important topic, that is stoichiometric coefficients and limiting reagents. So wait just a minute, let me open the YouTube so that I can see your comments, right? Yeah. Yes, Tej, we are starting now. Hope you are there. Okay. So now let's get started, right? Okay. Now let's see. Here you can see the full year course and what all courses are we are going to provide. Yes, we provide the courses for NEET as well as for JEE. So in our course you can see that we provide the PDF materials, we have the test series, and that is the 25 major test series we provide, and all with the NTA pattern. Okay, and there will be query solving with the teachers each 2 days. So also we have lessons, or okay, we have theory explanations will be there and assignments will be there. Yeah, Tej, how are you doing? Hope your preparations are going well, right? Okay. Yeah. So you can crack your JE or NEET with the enormous discount of rupees just 490 per month. Okay. So this is a very good chance for you. So you can join with our team and you can crack your exam very easily, and putting your effort. You will be given a we have a mentorship program who will guide you through this whole year of your preparation. So that will be a greater advantage for you, right? Okay. Now if you are new to this channel, you can subscribe to this channel. Okay, you can subscribe to this channel because we regularly give free classes in our YouTube channel, so it will be helpful for your preparation. So don't forget to subscribe. You can subscribe now and hit the bell icon. Okay. Yes. So myself, I'm Roshan Ahamed. I'm an MTech graduate, a National Olympiad winner. I have a 6 years of experience in teaching students, coaching students for NEET and JEE. Okay, I have already guided more than 1 lakh students to crack the exam. Okay, now this is all about me. Now let's move into the most interesting and the most important segment of mole concept, that is stoichiometric and limiting reagent. Okay, so let's discuss about the stoichiometry and limiting reagent. Before getting into the proper stoichiometric or limiting reagent concepts, first we will clear off what do you mean by the percentage of a compound. See, here you can see that what is the percentage composition. What does percentage composition means? Percentage composition of compound means it is the mass percent of each element present in the compound. The mass percent of each element present in the compound. What does that mean? I'll clear that. Okay, don't worry. So here we know that if you consider a compound, we know that a compound is a mixture of elements, right? If, for example, if you take water, you can see that in water we have hydrogen as well as we have oxygen. So the mass of water is a combination of the masses of two different elements, that is hydrogen and oxygen. So oxygen contributes certain mass to water, as well as hydrogen also contributes some mass to water. So we have to calculate what are the percentage of their composition, or what are the percentage of the contribution of each element towards the mass of a compound. So for that, let me do this example. What is the example? We are considering ethane, that is CH3CH3, or you can write it as C2H6. We have to find out the mass percentage of carbon and hydrogen. Here you can see how we are going to find out the mass percentage. So for finding out the mass percentage, mass percentage is equal to mass of an element divided by total mass of compound. and now you have to convert it into percentage, so that you have to multiply it with 100 in order to convert to percentage, right? So here you can see mass of an element. So let's calculate the percentage mass of carbon. So how much percentage of mass is contributed by carbon in ethane? That is what it means. Okay, what percentage of mass is contributed by carbon in ethane? So for that we have to know what is the mass of carbon. We know that mass of one carbon is 12 gram per mole. So here we have two carbon atoms. So two carbon atoms means 2 into 12, that is 24, right? So 24 divided by, what is the total mass of C2H6? Let's calculate it here. 24 plus 6 will give us the mass of C2H6, that is 30 gram per mole. How did I get that? Because we know that mass of carbon atom is 12. So two carbon atoms are present, so 2 into 12, and mass of one hydrogen atom is 1. There are 6 hydrogen atoms, so 6 into 1. So in total we get it as 12 plus 6. So in total we got the total mass of C2H6 or molecular mass of C2H6 as 30 gram per mole. Is that clear? So what is the percentage of carbon? Percentage mass of carbon is 24 divided by 30 into 100. So you can cancel it with 2. You can, yes, I can cancel a 0 over here, and I can cancel 24 by 3. 24 by 3 is simply but 8. So we can write it as mass percentage of carbon is 80%, right? Okay. Now let's see this. Now we will be calculating the mass percentage of hydrogen. So what is the mass percentage of hydrogen means? How much mass or how much percentage of mass has been contributed by hydrogen to the total mass of C2H6. Okay, so how many hydrogen atoms are present in the compound? We know that it is 6%. 6 hydrogen atoms are present. So I can simply write it as 6 divided by total mass of the compound is 30. So 6 by 30 into 100. Right? We can cancel the 0, and 3 and 2, 6 can be cancelled as 2, and so we get it as 20%. Right? So you get it as 20%. See, here actually if there is only 2 elements are present in a compound, once you find out the mass percentage of one element, then by another equation you can find out the mass of the second element. That means we know that the total mass percentage will be 100%. It cannot be more than 100%, right? So the total mass percentage should be how much? 100%. So I know that the mass percentage of carbon is 80. Then obviously the mass percentage of hydrogen will be 20. 100 minus 80, right? So in that manner also you can find out, and you can only find out when there is only 2 elements, right? If there is 3 elements, then you have to find the mass percentage of the 2 elements. Then you can subtract it with the 100, okay, in order to get the mass of the third element. Hope that is clear for you, right? Okay. So we'll move on to the next one. See, here we are going to calculate the percentage composition of glucose. Okay, so let's calculate the total mass of glucose. We have 6 carbon atoms, so 6 into 12 plus 12 hydrogen atoms, that is 12 into 1, plus we have 6 oxygen atoms, that is 6 into 16. You know the mass of one oxygen atom is 16. So 6 into 12 is 72 plus 12 plus 6 into 16 is 36 and 96, right? So here 100, 180. Total mass is equal to 180 gram per mole. So the total mass of glucose is 180 gram per mole. We have to calculate the percentage composition. So we know that there are 3 elements present. Here there is carbon is present, hydrogen is present, and oxygen is present. So we will be calculating the percentage mass of carbon. So percentage mass of carbon is equal to total mass of carbon present in the compound. How many carbon is present? 6 carbon. So the total mass of carbon is 6 into 12, that is 72, divided by Total mass of the compound is 180 into 100. In order to convert them into percent, we have to multiply it with 100. Yes? Okay. Now you can cancel these zeros. 1 0 here, I will cancel this 1 0 here. I can cancel this with 9. 9 2s are 18 and 9 8s are 72. And here again I can cancel this. 8 divided by 2 is 4. So 4 into 10, we will get the answer as 40%. 40%. Is it clear, Tej? Hope this is clear for you. If you have any doubt, please feel free to ask it in the comment section. Okay, now let's calculate the percentage hydrogen, percentage mass of hydrogen. So in order to calculate the percentage mass of hydrogen, we know that same rule. What is the mass of hydrogen? Total mass of hydrogen present in the compound, that is 12, right? We have 12 hydrogen atoms, so mass of one atom is 1. So 12 divided by 180 into 100. We can cancel the zeros. We can cut this 12 by 6, that is 2, and here also cut it by 6, that is 3. So 2 by 3 into 10, that is 2 by 3 means it is 0.67, right? It is 0.67. So we will be getting it as 6.67%. It can be 0.6666, it goes like that. Okay, so we will stop it by multiplying it with, I'll clear this. I need not want you to be confused. So here 2 by 3 means it is 0.666, like that it goes, and into 10. So that means 0.67%, sorry, 6.7%, right? So 10 means 6.66%. You can write it in that way also. 6.66% or 6.67%. You can just stop it there. Okay. Now we will calculate the mass percentage of oxygen. We know that the mass percentage of oxygen, we have 6 oxygen. So total mass of oxygen present in the compound is 6 into 16, that is 96, divided by 180 into 100. You can cancel the zeros, and here it is, you can cancel it by 2. 2 9s are 18, and here I can cancel it by 48. Okay. Now we can cancel it by 3. 3 3s are 9, and here 16 into 3 is 48. So 16 divided by 3, let's calculate 16 divided by 3. 16 divided by 3, that is 5 times 15, 1 balance. You give a decimal, 5.333, like that it goes. So 5.33 into 10, that means 53.33%. So these are the percentage composition of the elements. Percentage carbon, we got it as 40%. Percentage hydrogen, we got it as 6.67%. And percentage oxygen, we got it as 53.33%. Right? Yeah. I will move on to the next one. Now let's see. Here you are given with urea. Okay. Now first let us calculate the total mass. Total mass of ureas, we know that there is 2 nitrogen atoms. So for 2 nitrogen atoms, 14 into 2 plus 4 hydrogen atoms are there. So 4 into 1. So 1 into 4. Okay. Both are correct. And 1 carbon atom, that is 12. 1 oxygen atom, that is 16. So in total, you can calculate it as 28 plus 4 plus, again 12 plus 16 is 28. That means in total you will be getting a value of 60 gram per mole. 60 gram per mole. Right? Okay. Now we can find out each mass percentage of each element. So percentage N is equal to, what is the total mass of nitrogen present? 28 gram. So 28 divided by total mass is 60 into 100. Can cancel zeros. Here I can cut it with 2, so it will, we will be getting 3. Here I can cut it with 2, we will be getting 14. So what is 14 divided by 3? Here we can calculate 14 divided by 3. 14 divided by 3, 4 times, so it will be 12. to 4.66, right? So it will be, we will be getting 46.67%. That this much mass, this much percentage of mass is contributed by nitrogen to the urea. Okay. Now next we will be calculating the percentage mass of carbon. There is only one carbon present, so 12 divided by 60 into 100. You can cancel the zeros, and 12 divided by 6 is 2. So 2 into 10 is 20%. That's much easier, right? Next one is percentage oxygen. That is, we know that only one oxygen is present, so 16 divided by 60 into 180. Sorry, into 100. This zeros can be cancelled, and you can cut this 6 and no, that's not 18, right? That's simply 100. So yeah, we can cancel it by 2, right? We can cancel it by 2. So I'll get 3 here, I'll get 5 here. So 16 divided by 3. Let's calculate what is 16 divided by 3. So it is 5 times 15. 1 will give a decimal, so 5.33. We'll be getting a value of 5.33. So 5.33 into 5. What is 5.33 into 5? 5.33 into 5, 25, 26. 26.25%. 26.65%. So you have all the three elements. Now what is pending? Hydrogen is pending. If you want, you can add all the three percentages and subtract it from 100. So you will be getting the percentage of hydrogen. You can do that way, or you can do the same way. Percentage hydrogen is equal to, there are 4 hydrogen. So 4 divided by, what is the total mass? 60 into 100. Can cancel the zeros. And what is this is can be cancelled by 2. Here it will be 3. So 2 by 3 is 0.67. So we will be getting a percentage of 6.67. Okay. So these are the mass percentages of different elements or the components present in urea. Hope this is clear, right? Now we will move on to the next one. See, another concept is regarding the empirical formula. So how you are, first of all, let's understand what is empirical formula. See, empirical formula simply means the simplest ratio of atoms. It is the simplest ratio of atoms of different element in the compound. It represents the simplest ratio of atoms of different element in the compound. You may not get the concept properly by just reading that sentence. I'll make you feel what it means. See, first we will move on to what do you mean by molecular mass, molecular formula. Then we will come to empirical formula so that it will be easier for you to understand. Okay, now let's see here. We are given with an example of benzene here, right? So here you can see that benzene molecular formula is C6H6. What do you mean by molecular formula? Molecular formula represents the actual number of atoms present in the molecule, actual number of atoms. So in benzene we know that there is 6 carbon and 6 hydrogen. So what is the ratio there? 6:6, right? So if I wanted to convert this ratio into a simplest ratio, then what I have to do? I have to cancel the common term in that ratio. So here I can see that 6 is the common term in the ratio. So if I cancel them, I'll be getting 1:1. In that case, I can write the empirical formula of benzene as C1H1. You can understand that empirical formula is not the real formula of the compound. It is only the simplest ratio of atoms present in that compound. Okay, that means here we got it as actual molecular formula is C6H6. That means the ratio of the combination of atoms is 6:6. For 6 carbon atoms, there should be 6 hydrogen atoms. Can you convert that 6:6 into the simplest form? Yes, we can simplify it by cancelling the Common term is 6 here, so you cancel it, so you get 1:1 ratio. Does one carbon and one hydrogen combine together to form benzene? No. So empirical formula is only expressing a simplest ratio. So simplest ratio is obtained from the molecular formula by cancelling the common term. So let's take another example of C6H12O6, C6H12O6. See, this is the molecular formula. It is the actual number of atoms present in glucose. That means 6 carbon atoms is there, 12 hydrogen atoms is present, and 6 oxygen atoms is present. So here we can see that in all the 3 terms there is 6 is common. So I can cancel 6. So if I cancel 6, I will be getting 1:2:1. Now this is the simplest ratio. I can form the empirical formula by writing the simplest ratio. We have 1 carbon. For 1 carbon there should be 2 hydrogen and there should be 1 oxygen. So this is this the actual formula? No, it is only the simplest form of representation. That is called as the empirical formula, and molecular formula will give us the actual formula, right? Molecular formula will give us the actual number of atoms present in it. Hope this is clear, guys. Yes? Yeah. Now we will move on to the next one. So hope the empirical formula as well as the the molecular formula is clear for you, right? Now this note is very important. See, in certain question paper you will see that they will be giving you, or they will be asking you to find out the least molecular mass. What do you mean by least molecular mass? It is nothing but empirical molecular mass or empirical formula mass. We call it as empirical mass or empirical formula mass. So let's check it out. See, in the case of benzene, we got the empirical formula of benzene as C1H1. What will be the mass of this formula? That means we have 1 carbon and we have 1 hydrogen. So the mass of the empirical formula is 13. That is meant by empirical mass. That is meant by the empirical mass. As well as in the case of glucose, this is the original molecular mass, molecular formula of the compound. So what was the empirical formula? Empirical formula was C1H2O1. Then what is the mass of this empirical formula? There is 1 carbon, 2 hydrogen, 1 oxygen. That means in total we are getting a mass of 30. Right? That is simple empirical formula mass. Right? Okay. Now let's check this. We are asked to find out the empirical formula of acetic acid. Before going to that question, let's check this note again. So whenever you are asked, or if you are given in the question paper that the least molecular mass of a compound is this much, so you have to understand that the least molecular mass is denoting to the empirical mass. It is not the actual mass, or it is not the molecular mass. It is the empirical mass of the compound. That is what you have to be aware of. If you are also asked to find out the least molecular mass, don't find out the molecular mass. You are asked to find out the empirical mass. Okay, that should be kept in mind. Right? Now, find the empirical formula of acetic acid. You have to find the empirical formula of acetic acid. First, you have to write the molecular formula of acetic acid, that is CH3COOH. So here you can see that this is the molecular formula. So first you have to write the ratio, the actual ratio. So for that I have to rearrange the atoms. I have to bring, there is 2 carbon atoms. So I will write like this, 4 hydrogen atoms and 2 oxygen atoms. You will just rearrange that in this manner, so that you can just write the ratios 2:4:2. 2:4:2. Now what is the common number? Common number is 2. 2 is common in all the 3 cases. So you can cancel that through 2 and you will be getting 1:2:1. Right? So 1:2:1 is the simplest ratio. Now we can represent the empirical formula as C1H2O1. And for our surprise, we got the empirical formula of glucose as well as empirical formula of acetic acid, both are same. Right? So hope this is clear for you. Now we will move on to the next one. See, calculate the empirical formula by percentage composition. This is one of the interesting topic over here. They will give you the percentage composition of carbon as well as hydrogen or any different elements. The percentage composition will be given. You have to find out the empirical formula. How we are going to find out? Let's see. First, you have to write this element. Okay, elements are carbon, hydrogen. The second column is percentage mass or percentage. Percentage is simply you can write it as 80 and 20. So we will consider it as 80 gram and 20 gram. That's how you have to calculate. Okay, whatever the percentage is, it indicates a percentage mass. So you can consider it as the total mass of the compound is 100 gram. So the mass of carbon will be 80 and mass of 80 gram and mass of hydrogen is 20 gram. You can do it that way. Okay, it's not a problem. Now, in all the cases, you can do the same manner. Now you have to find the number of moles. So we know the number of moles is equal to weight by molar mass, right? So weight is given as 80. What is the molar mass of carbon? That is 12. Okay. Here we know that it is 20 divided by molar mass of hydrogen is 1. Okay. Here I can cancel it with 2. So it will be 40 and 6. Here it will be 20 and 3. 20 divided by 3. So we are getting a number of moles as 20 by 3. Here the number of moles is 20. Now I have to find out the mole ratio. Mole ratio. So what is the mole ratio? Here what you have to do, which is the minimum value? Minimum value is 20 by 3. So in order to find out the mole ratio, you have to divide the number of moles by the smallest value you got. Here I got the smallest value is 20 by 3 and largest value is 20. So I have to divide, in order to get the mole ratio, I have to divide 20 by 3 with the same mole ratio. Okay, that is, we have the 20 by 3, which is the smallest value. Smallest value is 20 by 3 itself. So we can cancel this and I got the ratio as 1 here. And in the second case, I have 20 moles here. I have to divide with the smallest value. Smallest value is 20 by 3. So I cancel this and I get a value 3 here. So the mole ratio is 1:3. That is what we have to, we actually require. So here you can write the empirical formula, that is, for 1 carbon, we require 3 hydrogen. This is the answer for the question given. So what are the steps? First you write the element, then you write the percentage, okay, percentage mass, then convert them into number of moles. How you have to convert them? We know the formula, weight by molar mass or weight by gram atomic mass is the number of moles. So we know that the mass of carbon atom is 12. So 80 divided by 12 will give you the moles. So we got the answer as 20 by 3 moles, and in the case of hydrogen we got the answer as 20 moles. Okay, that is weight of percentage weight of hydrogen is 20. So 20 divided by molar mass, that is 1. So 20 divided by 1 is equal to 20. So from this, both the ratio, which is the smallest one? Smallest one is 20 by 3. So in order to find out the mole ratio, you have to divide both the number of moles by the smallest value, that is 20 by 3. Here I divided by 20 by 3, I got the value as 1. Here I divide by 20 by 3, I got the value as 3. So that is the simplest mole ratio, and that simplest mole ratio is expressed here to find out the empirical formula. Hope this is clear. Now we will move on to the next question. If the vapor density is 15, calculate the molecular formula. Before finding the answer, let me clarify here. That is, how to find out the molecular formula. Molecular formula is equal to empirical formula into n factor. It is empirical formula into n factor. What do you mean by n factor? N factor is equal to molecular mass divided by empirical mass. Molecular mass divided by empirical mass. So dear students, we already got the value, the empirical formula. We already got the empirical formula here, right? We got the empirical formula here. Now we have to find out the molecular formula. So now I told you that in order to find the molecular formula, what is the equation to find out the molecular formula? That is empirical formula into N. So how you are going to calculate N? N is equal to molecular mass by empirical mass. Okay. So what is the empirical mass? Let's check the empirical formula again. It is C1H3. C1H3. So empirical mass is equal to, I'll write it as EM. Empirical mass is equal to C1H3, that is 12 into 1 plus 3 into, right? 12 is the mass of carbon atom and 1 is the mass of hydrogen atom. So 12 plus 3, we get the mass as 15. Okay. Now we want to get, or we want to find, in order to find out N, we require what? We require molecular mass now. But instead of molecular mass, they have given us vapor density. So you should know this equation, that molecular mass is equal to 2 times vapor density. So very important equation, very important formula, that is molecular mass is equal to 2 times vapor density. This is also, you have to put it in a box. Okay, so vapor density, see, in the question papers, in the previous year question papers, either they will give you molar mass directly, molecular mass directly, or in order to twist the question, they will be giving you vapor density. So once you know the formula of the connection formula of molecular mass and vapor density, then it is easy for you to find out the molecular mass. So molecular mass is equal to 2 times vapor density. That means molecular mass is equal to 2 into 15, that is equal to 30. Now we can find out the N. N is equal to molecular mass by empirical mass. So 30 divided by 15, you will be getting the value as 2. Now what is molecular formula? Molecular formula equal to empirical formula times N. That is, empirical formula is C1H3, C1H3 times 2, that is C2H6 is the molecular formula of the given compound. Is it clear, students? Please let me know in the comment section. This is one of the important topic from chapter mole concept. Now let's see another one. Percentage composition by mass of a hydrocarbon. See, they have given us a hint that the compound is simply hydrocarbon. So in hydrocarbon, we know that there is only 2 elements. One is hydrogen, the other is carbon. Okay. And they only gave us the percentage of carbon. They didn't give us the percentage of hydrogen. Right. So we need to find out the percentage of hydrogen also. First, we have to find out the percentage of hydrogen. For that, we know that percentage carbon is equal to 600 by 11. So in order to find the percentage hydrogen, you can subtract the percentage carbon from 100. So I'll subtract the percentage carbon from 100, because percentage carbon and percentage hydrogen together combines to form 100%, right? If you know the percentage of carbon, then if you see here, I'll give you one idea, that is percentage carbon plus percentage hydrogen. In total, if you sum it, you will be getting it as 100. So if you want to find out the percentage hydrogen, then what you have to do? 100 minus percentage carbon, right? So here I am doing it, 100 minus percentage carbon, that is percentage carbon is 600 by 11. Okay. So 600 by 11 means 1100 minus 600 divided by 11 means 500 by 11 is the percentage hydrogen. Percentage hydrogen is equal to 500 by 11. So now we got the percentage carbon as well as already given. Percentage carbon is already given. Percentage hydrogen also we got it. So let's write it here. Let me rub this. Okay. Hope this is clear for you. So I'll rub this off, because we do not have much space here. Okay. So now elements are carbon and hydrogen. Their percentage weight is given as 600 by 11, and here we have 500 by 11. Now we will find out the moles. Moles is percentage weight divided by molar mass. So 600 by 11. What is the molar mass of carbon? That is 12. Okay. So you can cancel it with 6 here. You will be getting 100, and you can cancel it with 2. Sorry, 6 here. So it will be 2, and 2 and 100 can be cancelled. You will be getting it as 50. So you will get it as 50 by 11. Okay. Now what about the mole of hydrogen? We know that the mass of hydrogen is 1. So you can just write it as 500 by 11. Next is we have to calculate the mole ratio. Mole ratio. So for finding the mole ratio, I told you from the two values, which is the smallest one? Smallest one is 500 by 11. So we will divide both the moles with 50 by 11, not 500 by 11, 50 by 11. So here you can divide it 50 by 11 divided by 50 by 11. That means it is 1. Now what about 500 by 11 divided by 50 by 11? It will be equal to 10. So we got the mole ratio. Now that's enough for us to find out the empirical formula. So empirical formula is equal to C1H10. C1H10. Yes students, hope this is clear. It's a very good question. It was a previous JEE question. They only given us the percentage carbon. Okay. Then by using your common sense that percentage carbon and percentage hydrogen together forms 100%. So from that we calculated, or we found out what is the percentage of hydrogen, and we got it as 500 by 11. Now the normal steps. We got the percentage masses. Now we put it as mass and we calculate the moles. Then we find out the mole ratio by dividing the number of moles with the smallest value. Okay. So we got the simple ratio, and that simple ratio giving represented along with the letters of the elements, we get the empirical formula. Okay. Yeah. Now we will move on to the next one. See, this is a previous JEE advanced question. See, this is not that easy. Here there is a very good concept also. So let's do it together. Here you can see the percentage composition by mass of a compound is as follows. That is, percentage nitrogen is given as 26%, percentage oxygen is given as 74%. You are given with 4 options. That is NO, N2O3, N2O5 and NO2. By understanding the percentage composition, by calculating, you have to find out the molecular formula or the empirical formula of the compound, and you have to tick the correct one, which is the correct one. Okay. So let's do it. We have 2 elements. So elements are nitrogen and oxygen. Percentage mass is given as 26 and 74. Next we have to calculate the number of moles. For moles, we have to divide the percentage mass by molar mass, that is 26 divided by 14 and 74 divided by 16. Mass of nitrogen is 14 and mass of oxygen is 16. So here you will be getting, if you divide it, you will be getting 1.85, and if you divide here, you will be getting 4.625. Now we know that this is the smallest value. So in order to find the moles ratio, you have to divide the number of moles with the smallest value. So 1.85 divided by 1.85, you will be getting a value of 1, and here 4.625 divided by 1.85, you will be getting a value of 2.5. Yes. So here see, dear students, here the ratio is 1:2.5. If you are getting a decimal like this, convert them into fraction. That is 1:5 by 2. 2.5 can be represented as 5 by 2. Normally what students does is that if they get the value as 2.5, they either convert them into 3 or they convert them into 2. They may take it as 2 or they may take it as 3, because empirical formula does not contain any fraction or a decimal. So what you have to do is that you have to convert that decimal into fraction. So you will be getting it as 1:5 by 2. So here let's check this. Here I have nitrogen 1 and oxygen 5/2. And see, we cannot represent the molecular mass or empirical mass or empirical formula or molecular formula with a fraction. So in order to convert this fraction into a whole number, I have to I have to cancel the denominator. For cancelling the denominator, I have to multiply 2 with both the values. So in order to cancel out, we will multiply 2 with all the values. So here we will be getting N2 and here we will be getting O5. And the denominator 2 will be cancelled when you multiply it with 2. Okay. So the answer is N2O5. Option 3 is the correct one. Normally students go for either for this one because they get here 1 and they get here 2.5. So they will round this 2.5 to 2 by approximation, and that will be a blunder. Okay. So be aware of that. And also as a trick, I am going to give you certain values. So you have to be aware of this. That is, if you are getting a ratio of 1:2.5, then what you have to do? You have to write it as 1:5/2. Or else if you are getting a ratio of 1:1.33, okay, 1.33, you have to represent it as 1:4/3. This is the ratio corresponding to that value. Okay, and similarly, if you are getting a ratio of 1:1.25, you can represent it as 1:5/4. So always remember these values. This is a trick to do such problems. Okay, always remember these values. This is the trick to do such problems. Whenever the students get a fraction or a decimal like this, they always round it off to 1 and they click or they bubble the wrong answer and the marks will be gone. Okay, so you should be aware. This is the very important step from this section. So this will be the type of questions that may be asked for the competitive exam. Okay, so you have to be very much aware of this. So I hope this is clear for you. You can note these values there. That is 1:1.33 is equal to 1:4/3, 1:1.25 equal to 1:5/4, or if it is 1:2.5, then it is 1:5/2. Only these three values you have to study. No other values will be asked for your exam. Okay, right. Now next is mole analysis. See how you are going to do the mole analysis. I'll give you a hint on how to do the mole analysis. Mole analysis is the much easiest step in mole concept to find out the moles of the product. Okay, normally students struggle with this, but this is the trick, or this is the easiest step to find out the to find out the number of moles of the product, as well as I'll teach you a trick to find out the limiting reagent. Within seconds you can solve the problem. Limiting reagent, within seconds you can solve the problem. So keep waiting. Here I'll give you an example of mole analysis. So before that, if you have any doubt, please let me know. Until here, is it clear for you, or is there any doubt? Please let me know. Okay, I hope everything is clear. If so, then let me move on to the mole analysis. Yes, students. Okay. Yeah. So now let's discuss what is mole analysis. So I'll give you an equation, a formula, or what you can say that a chemical reaction, that is N2 plus 3H2 giving 2NH3. This is the chemical reaction. Okay. Now let's check this. What is mole analysis? The mole analysis says number of moles of N2 by stoichiometric coefficient of N2. Sir, what is stoichiometric coefficient? See, stoichiometric coefficient means here there is a number 1 behind N2, but we generally do not represent 1 while writing the chemical reactions. So that number is called as stoichiometric coefficient. Here you can see behind hydrogen, you can see 3, number 3. That is the stoichiometric coefficient of hydrogen. Here you can see behind ammonia, you can see a number that is 2. That is called as a stoichiometric coefficient of ammonia. Okay. Now mole analysis says number of moles of N2 by stoichiometry of N2 is equal to number of moles of H2 by stoichiometry of H2 equal to number of moles of ammonia by stoichiometry of ammonia. Okay. Now see this, number of moles of N2 by stoichiometry of N2 is 1, number of moles of H2 by stoichiometry of H2 is 3, and number of moles of ammonia by stoichiometry of ammonia is 2. See students, you will be given the number of moles values or some values that will help you to find out the moles of the reactants. Either they directly give you the number of moles of the reactants, or they will give you the mass of the reactants, so that you can find out the moles by using the formula W by molar mass. Okay. Now once you get the mass or the number of moles of the reactants, you will be asked to find out the number of moles of the product. So you can use this equation easily to calculate the number of moles of ammonia. You can either connect these two or you can connect these two, and you can find out the number of moles of ammonia. That's how the mole analysis works, and it is the most simplest way to find out the limiting reagent or the number of moles of the product, etc. Okay. Now we will do some problem. So in mole analysis, you will be having two cases. What are those cases? The first case is that if moles of reactions are taken in same ratio as stoichiometric coefficient ratio, all reactants may be consumed completely. What does that mean? Let's give you an example. Here you can see that how many moles of ammonia are formed by a reaction of 3 mole of N2 and 9 mole of H2. So this is an example. So before going into that question, let's clear this concept that if I take this N2 plus 3H2 giving 2NH3, this is the reaction, right? Now let's see the stoichiometry. Stoichiometry, here it is 1, here it is 3, here it is 2. Now I am telling you, I have taken the number of moles of nitrogen as 3 and number of moles of hydrogen as 9. Okay. Now let's see this ratio. This ratio is 1:3. That means the ratio of stoichiometry is 1:3. What about the ratio of number of moles? Number of moles ratio is 3:9. That means it is again 1:3 only. Common term you can cancel, and you are getting the same ratio as that of stoichiometric coefficient. So what case 1 says is that if you have the same ratio of stoichiometry as that of number of moles, then both the reactants will get completely consumed in the reaction. That means after the completion of the reaction, reactants will not be present in the reacting medium. That means whole of the reactants will get consumed. That means there will not be any case of limiting reagent. No limiting reagent or excess reagent will be there. Both of them simultaneously get completed in the reaction medium. So this is the concept you have to get. If the ratio of the stoichiometry as well as if the ratio of the number of moles of the reactants are same, then both the reactants will completely get consumed in the reaction. Now, so we have another case here, right? Logically, you can think that there will be one more case. What will be that case? That case will be if the stoichiometric ratio and the moles ratio are different. Then the case is different, right? If the stoichiometric ratio and the moles ratio are different, then obviously there will be excess reagent as well as limiting reagent. Okay, so let's check this out. I will give you an example here. The same example we will take it, and I will change the number of moles. I will simply change the number of moles here. So instead of this, I will give you 2 moles and 4 moles of hydrogen. So here you can see that the number of moles of nitrogen and hydrogen have a ratio of 1:2 after cancelling the common term. So here the mole ratio is 1:2. Here the stoichiometric ratio is 1:3. That means the stoichiometric ratio and mole ratio is different. So there will be, this case is the case of limiting reagent or excess reagent case. Limiting reagent means That is the particular reagent which get consumed completely. Excess reagent do not get consumed completely. In fact, after the reaction get completed, the concentration of the excess reagent will remain behind. The concentration will be present there. That means the excess reagent will be left over after completing the reaction. Okay, only limiting reagent will get completely consumed. Okay, so these are the two cases that you have to study. Hope that is clear. Okay, now let's do the problem by using the mole analysis, and you can easily feel that how easy this step is, right? Now let's take this. You will enjoy this, right? Mole analysis. So let's write the equation chemical reaction N2 plus 3H2 giving 2NH3. First of all, while using mole analysis, you have to ensure that the given reaction is balanced. If the given reaction is not balanced, then you have to balance the given reaction, then only you have to use the mole analysis, otherwise it doesn't work. Okay, always ensure that the given reaction is balanced. Is that clear? Yes? Okay. Now see, first we will write the stoichiometry. Stoichiometry, here it is 1, here it's 3, here it's 2. Okay. Now what are the number of moles? Number of moles of nitrogen is 3, hydrogen is 9. So 3:9 means it is 1:3 only after cancelling the common term. That is, the common term is 3. If you cancel it, you will be getting 1:3. So that means the number of moles of the stoichiometric ratio as well as the moles ratio are same. Now you are asked to find out the how many moles of ammonia. Just apply the mole analysis. What is mole analysis? Number of moles of N2 by stoichiometry of N2 equal to number of moles of H2 by stoichiometry of H2. So let me give the stoichiometry here itself. Okay, number of moles of N2 by stoichiometry of N2 is 1, stoichiometry of H2 is 3, and that is equal to number of moles of ammonia by stoichiometry of ammonia is 2. Okay, now you can just connect these two equations to find out the number of moles of ammonia. Just put the value of number of moles of hydrogen here. What is the value of number of moles of hydrogen? It is 9. So just substitute the value. So you will be getting 9 by 3 equal to number of moles of ammonia by 2. So you can cancel this with 3. You will be getting 3. So number of moles of ammonia equal to 3 into 2, that is 6. 6 moles. Most easiest step to calculate the number of moles of the product. Okay. Now we will move on to the next one. Hope this question is clear for you. Hope the mole concept is clear for you. So this we have already discussed that if you are considering the case 2 we know that the case 2 discusses about the mole ratio and the stoichiometric ratio, both are different. If the mole ratio and stoichiometric ratio are different, then among the two reactants, one reactant is completely consumed, and that reactant which get completely consumed is called as limiting reagent. And the reagent which get left over even after the completion of reaction, that reagent is called as the excess reagent. Okay, Tej, hope it is clear for you, right? Have you studied this before, the mole analysis? Please let me know. Okay, so this is the case. Now I will give you a trick to easily find out, within seconds you can find out the limiting reagent. Okay, it was previous one. Okay, now let's see this. I am giving you a question that is N2 plus 3H2 giving 2NH3. Okay, now I am telling that the number of moles I am giving you as, here it is 3, here it is 6. Okay, so how to find out the limiting reagent? You have studied it, you don't remember now. Okay, very good. Now how to find out the limiting reagent? The only thing you have to do is that just write the stoichiometry 1, 3, 2. Now just do this fraction n by SC. N by SC means number of moles, that is 3 by 1, and here 6 by 3. 6 by 3 is equal to 2. Now you know that from this equation, that is the number of moles and the stoichiometry are different. The ratio of stoichiometry is different and the moles ratio is different. Okay. If the moles ratio and stoichiometry are different, then we know that what? There will be limiting reagent. Now to find out the limiting reagent, this is the easiest step. Just find out the value of n by SC. Just find out the value of n by SC. Here you got the value as 3 for nitrogen. Here you got the value of 2 for hydrogen. So whichever value is smaller, that reagent will be your limiting reagent. So by simply looking at that ratio, you can easily find out the number of or the limiting reagent present in the reactants. Okay. Now, the very important point that you have to remember here, if the reaction consists of limiting reagent, then in the mole analysis, I'll write it over here. In the mole analysis, you have to be aware that you should not put the values of the excess reagent. You only have to put the values of the limiting reagent. We know that mole analysis is equal to number of moles of N2 by 1 equal to number of moles of H2 by 3 equal to number of moles of NH3 by 2. This is mole analysis. Here, if the case is of limiting reagent, then you should not give the value of excess reagent. You only have to connect it with the limiting reagent. Okay, only put the value of limiting reagent. If you are not putting the value of limiting reagent and if you are connecting the excess reagent with the product, then your answer will go wrong. So be aware that if the reaction consists of the limiting reagent, then only put the value of the limiting reagent and find out the value of the product. Okay, here what is the number of moles of H2? The number of moles of H2 is given as 3. So 3 by 3 equal to number of moles of ammonia by 2. That means number of moles of ammonia is equal to. So this is how you will calculate. This is how you will calculate the number of moles of the product when a limiting reagent is present. Yes, I hope this is clear for you, Tej. If you have any doubt, please let me know. Shall I give you a question so that you can do that? So let's do a question. Okay. Here, let's do a question. Okay. I'll give you a reaction. We'll take the same reaction N2 plus 3H2 giving 2NH3. Okay. Now, I have taken it as 4 moles and I have taken this as 8 moles. This is the number of moles. Okay, number of moles. And find out the number of moles of ammonia. This is the question. Find out the number of moles of ammonia. Or you can also find out the number of what's the mass of ammonia. Mass of ammonia. So first you can find out the number of moles of ammonia, then convert it into mass. So let's do it together. Here we have the stoichiometry as 1 and 3. First we know that here the ratio is 1:2, here it is 1:3. Then obviously there will be what? There will be limiting reagent. So in order to find the limiting reagent, just do n by SC. N by SC, here it is 4 by 1, here it is 8 by 3. So 8 by 3 means 2 point something. So obviously hydrogen will be the limiting reagent. Okay. Now just give the mole analysis. So remember, what is the limiting reagent? Whichever element is the limiting reagent, then only use that. Okay. So number of moles of H2 by stoichiometry of H2 is 3 equal to number of moles of ammonia by stoichiometry of ammonia is equal to 2. The number of moles is 8 by 3 equal to number of moles of ammonia by 2. So you will be getting the value number of moles of ammonia is equal to 16 by 3 moles. 16 by 3 moles. Now we can find out the mass of ammonia or weight of ammonia. We know that weight by molar mass will give us the number of moles. So number of moles we got it as 16 by 3. Now in order to find the weight, it is 16 by 3 into molar mass. What is the molar mass of ammonia? We know that it is 14 plus 3, 14 plus 3, that is equal to 17. So 16 by 3 into 17 gram per mole is the answer, or 16 by 3 into 17 gram. So Ka, so 16 into 17, what is 16 into 17? It is 42, 4, 7, 1, 7, 11, 1, 6, 1, 1, 272. 272 by 3 grams. 272 by 3 grams. Yes. Hope it is clear. So this is all about the mole analysis, the limiting reagent. Normally the limiting reagent concept is very difficult for students. They might find it difficult to find out the values. Okay. You can see in the NCERT textbook also there is a solved problem regarding ammonia by giving the mass of compounds. Instead of giving the number of moles, they have given the mass. You can solve that. You can try to solve that page. Okay. You just try to solve it. So for that, what you have to do, you have to convert the given mass into number of moles. We know that if mass is given or weight is given, in order to find the number of moles, you have to do weight by molar mass. So there they have given the weight. So you have to first convert them into number of moles and use N by SC to find out the limiting reagent. Okay. So hope this is clear. And you need to practice more and more questions. So as you practice more and more questions, you will be an expert in this. So always the practical chemistry, or you can say the physical chemistry, always requires more practices with the numericals. Okay, then it will be easy for you. And mole concept is one of the beautiful chapter, or one of the easiest chapter from the physical chemistry, and you have to always remember that this mole concept is the basis for all other physical chemistry chapters. Even if you take electrochemistry, you will find the application of mole concept there. If you take the chapter solutions, you will find the mole concept there also. Okay, so Ashu, thank you so much for your lovely comments. Okay, and I hope I can cooperate with you in the upcoming days. And you need to, if you love this, please share the link of our videos so that other students can also take benefit from it. Okay, I know that these contents are not easily available on YouTube. Normally contents are there, but these contents like the finding out of limiting reagent or mole analysis, they never give it for free in the YouTube, but we are doing that. So you can just share it with more your friends, those who cannot afford to do the coaching. Okay, so we are doing it for free, so you can just share the link. Okay, so hope this is clear, and let's see in the next chapter. So the next chapter will be going through atomic structure. So we have completed the first chapter, that is some basic concepts, in the 3 sessions, I believe. Okay, so thank you students, thank you for your love, and take care. Bye bye. We'll be seeing with the next chapter soon.